Pleasure to introduce Pete Block talking about doing the hardware.
It's Pete Black, actually.
Pete Black, apologies.
Yes, thank you. Hello everyone, I'm Pete, and I'm going to talk to you today about just a few things about VR on Linux, and also a little bit about Vulkan and some of the applications of Vulkan and VR and Linux and some other stuff. Whoops, that's the wrong keyboard. So just quickly a little about me. I'm Pete Black. That's my Twitter handle. If you're interested in following that, I keep a bit of a devlog there. So a lot of my kind of independent work, I just kind of post stuff about what I'm doing. It is mostly concerned with virtual reality and 3D graphics. I'm from Wellington, New Zealand. I'm an independent graphics developer, which basically means unemployed most of the time. Most of my interests or sort of tools, I suppose, at the base level are C and C++. 3D graphics and virtual reality. That's where I've found a real interest and passion in things. VR is one of those things that you kind of try it out, and it's sort of, for me, it's almost like a new way to interface with the computer. It's quite exciting to be able to wave your hands around and interact with things in a very large scale way. Part of my background, along with sort of a lot of the systems and programming stuff that I used to do, touched on interactive exhibitions, which is for museums and things, which was another area where I sort of really got a lot out of, larger scale interfaces and being able to sort of, reach out and touch things and move things around rather than, try and mess around with things in a little rectangle in the palm of your hand or have everything confined to a rectangle on the wall. Breaking out of that, for me, is really interesting. And really, to sum up, my story, it's kind of like this, there's the clown in the sewer who invites you to, learn 3D graphics, and that's me down the bottom there. I just went in there and I haven't come up, So to get away from that, I thought I'd talk a little bit about, what is Vulkan, because perhaps some of you in the room aren't, hardcore 3D graphics developers and aren't really familiar with what Vulkan is and why you might use it. Vulkan is a low-level 3D graphics API. It's been created by the Kronos group, who are also the standards group, industry standards group, behind OpenGL, which is much more widely known. It's the new hotness, I suppose you could say. Vulkan is based on a specification released by AMD called Mantle, which they sort of tried to get out there as something that was going to be a way to get a lot more efficiency in games and other 3D interactive stuff. But no one in the developer community really wanted a third standard. And so AMD, to their credit, really did the right thing and sort of contributed that to Kronos, and it became the basis of Vulkan, with a lot of other input from other industry players, which you kind of see down the bottom of the screen there. What came out of that lengthy process really is an exceptionally good specification. It's very, very solid. Everything that you might want to know is kind of detailed in the Vulkan specification. In a way that it sort of isn't in the OpenGL specification. There's not a lot of ambiguity. It's a very, explicit and very well-defined spec. So, thumbs up to the Kronos guys and girls for that. One of the things about Vulkan is it has explicit memory allocation synchronization. This is something that OpenGL did not expose, and was a bit of a problem for a lot of the lower level things that you might want to do with a GPU. Another thing that Vulkan has that other APIs don't is a bytecode shader format. This is something that I think that DirectX has. I don't do a lot of work with DirectX, but this is great if you are, shipping shader code with your application that you actually want to run the same way on multiple different drivers and things. SPIR-V makes that a little bit easier and more consistent across drivers, across platforms. it's generally a good thing. And of course, it has a number of front ends, so you can compile GLSL or other languages as you like to target this intermediate format. Vulkan, and I suppose the thing for me that is exciting most is its high performance potential. Vulkan solves a lot of the problems that OpenGL has with regard to, I guess, draw call overhead is the primary one, or the primary problem. You can get a lot out of Vulkan. Some other cool stuff about it is API interoperability and inter-process communication, which I'll sort of touch on a little bit later in one of the projects that, this work that I've done independently has kind of led me to. But this is something that OpenGL never defined, something that has been sort of pushed, I guess, into the DRM layers of the kernel, things like that, where it becomes a little bit tricky to expose cross-vendor, especially when you're talking about NVIDIA. And another great thing about Vulkan is that it's supported on Windows, macOS with a asterisk there because Apple kind of backed out of the whole Vulkan standards process. Arguably, they had good reasons, but a company had created a sort of a wrapper layer that lets you write or target Vulkan on top of their Metal API, and so that's called Molten VK, which you'll see there. But it does work really well, and it means you can run Vulkan code on Mac OS X, which is nice. I did it again. And so, one of the questions that, it all sounds good, right? Vulkan, oh, wow, it's low level, it's really fast, it's really neat, it's got all this cool stuff. Why not Vulkan? Why wouldn't you target Vulkan? And, some of the reasons are that it's not for everyone. The programmer, when you're writing Vulkan code, is responsible for everything. And I mean, this is probably not such a bad thing for people who do low-level programming in other areas, even if it's not graphics. But people who just want to put a model or a triangle on screen, it's a significant amount of boilerplate and a significant amount of overhead. So, I wouldn't sort of downplay that. It's hard. It has a very steep learning curve. I've been working in 3D graphics for quite a while, and it's one of those things where you kind of get to the end after doing all of the stuff, which I'll sort of cover over the next few slides, and you sort of look back and go, wow, that was really hard. It was super cool to do that because I love learning stuff. That gives me a real buzz, but super hard. It's hard to port existing code bases, because Vulkan does so much in such I suppose, a different way to OpenGL or DirectX or, some of the other 3D APIs that might be in use on consoles or on Android, etc. It's just quite hard to fit that, I guess, square peg into the round hole. And so you sort of end up contemplating, oh, maybe I should just rewrite the whole thing in Vulkan, and that just becomes an enormous amount of work. And for all of those reasons, there's a little bit of a lack of a community. If you go onto the internet and you type into Google, how do I do this in OpenGL, you'll get a really good answer. If you do the same thing with Vulkan, a lot of people have, some pretty strong opinions on how things should be done in the Vulkan world, often driven by, I guess it attracts a bunch of people who are very focused on performance and very focused on efficiency and all that stuff. So, it's just there's less of a community, there's less of a critical mass of people using it. So, that tends to be a little bit difficult for people approaching it. Modern hardware only. You can't get your crappy old graphics card from the 90s. It's not going to run Vulkan. Doesn't matter who the vendor is, Intel, AMD, NVIDIA. You have to have a reasonably modern GPU to run Vulkan. This is in some ways, not such a bad thing. People tend to update their GPUs more often. There's a bit more of a churn, but anything below, I guess, NVIDIA 6 series, I think. Anything older than an AMD R9, I think. I can't really talk too much about Intel because I don't quite know, but there's a bit of a cutoff point there. Maybe it's Haswell or something like that. Anything older than that just doesn't support Vulkan. And another thing is also it's a bit of a departure from OpenGL conventions around coordinate spaces and things like that. So it tends to be quite hard to take something that works currently in OpenGL and just do a straight port to Vulkan. You know, it really requires a bit of re-architecture and I guess actually quite deep knowledge about how things get from, the coordinate space that you define your models in to the coordinate space that actually ends up on the screen. And if you don't have an understanding of that, Vulkan will trip you up. So moving along from Vulkan to the state of VR on Linux, which currently is, I'd have to say quite poor. It's coming along though. Most of my work with VR on Linux has been done with SteamVR and OpenVR, but it has to be said that the day one Linux support announcement that Valve made, way back in the day, didn't really happen, and there was, at least a year lag time. But that being said, OpenVR and SteamVR on Linux actually works pretty good now. So props to them. OpenHMD has been, that's the other, I guess, API that you can target for doing VR applications on Linux. It's been around for a long time. Unfortunately, I think most of the people who work on OpenHMD have better things to do, I guess. Paid work probably that keeps them from really doing a great job of providing a complete API, and so there's no positional tracking, which is a huge lacking feature there. Oculus, they started out supporting Linux. You could buy a DK1. This is actually the path that I took to virtual reality. I tried out a DK1 at some conference over in the States sometime. I think it was the GTC. I thought, wow, this is great. This is just good enough to be a useful tool. Came home, immediately ordered one. They had Linux support, they had OS X support, they had Windows support. It was great. And then they got Facebooked and all that stopped, which kind of sucks. So that was Oculus. OSVR was another interesting effort from, I believe, Sensix, who've got a long history in, I guess, scientific, military, industrial VR, and Razer, who are a 3D gaming peripheral manufacturer. They tried to sort of drive their own standard. Didn't really work out. It's basically dead. I don't believe when it was alive they ever actually got their positional tracking working on Linux. So that was disappointing, but they've now sort of folded themselves into the OpenXR standards process, which is the next big thing, if it ever makes it out of the Chronos standards process, which I don't really have any knowledge of, so I'm not really sure. And of course, the other big dog in virtual reality is Microsoft with their Windows Mixed Reality. That doesn't run, will never run, forget it, kind of crap. But hey, that's what you've got to deal with. Some other industry players, Apple, Google, Intel, Leap Motion, Magic Leap. Generally no support for Linux. There's a fair bit of support for Android, especially Google and Magic Leap. Their platforms are based on Android, but there's nothing really that you can sort of use to do VR development or AR development on Linux. And the other side, I suppose, of VR development, most people don't really go down to the low level. They don't go down to those APIs. And this is probably one of the problems when you decide, oh, I want to do a VR application and I want to use Linux. Almost everyone else in the industry is using Unity or Unreal to do this type of application because it just has so many features and so much stuff is done for you. But neither Unity nor Epic are particularly interested in providing support for Linux as a first-class citizen at all. Unity's got some stuff in the pipeline, but in my experience, it just hasn't really worked. Certainly not well enough to actually ship a product to a user. Godot, which is a game engine that is open source and very heavily Linux-based, they've got pretty good support. They're supporting OpenVR and OpenHMD, so that's probably your best bet if you want something that isn't very code-based and requires you to go down to a very low level and write some, pretty tricky 3D code. Probably if you can make it work in Godot, you can probably get it to run in VR maybe with one of those APIs. Blender is also a big supporter of VR and for their tools. Creative tools in VR are really exciting. Unfortunately, I think a lot of their code is a little bit legacy and very OpenGL bound. So I'm pretty sure that most of their stuff tends to be Windows only at this point in the VR space. But I'm sure that they are very interested in moving that forward. And also WebVR. I actually wrote some patches to Firefox when I was working with Mozilla recently. So that hopefully will be coming down the pipeline, but nothing from Google, the Chrome browser, or anyone else. And those, that support isn't quite perfect yet. So I'll cover that a little bit later. And some of the reasons for that is rewriting in Vulkan just for VR is a huge ask. And the reality is that OpenGL doesn't really provide enough performance, and there's a bunch of driver level problems that prevent it working really well with the approach, at least that Valve has taken with SteamVR and OpenVR, to get that stuff on the screen with the latencies that are necessary for VR. And the other problem really is that, for the creative community, and anyone who's doing game development or, I guess content creation on, for any reason, it's, the path of least resistance when it comes to these commercial engines is just so much. There's just, it's just so much easier just to say, well, I could write my own engine, or I could just use Unreal or Unity, and I could just use Windows. That is just too easy a choice for them to make. And so I'll just cover just how, like what I use just to, do stuff on a day-to-day basis. I mostly use Fedora. I use the LXQT desktop just because it doesn't have a compositor, so that just cuts down my problems. I use Qt Creator as my IDE. I like to use IDEs rather than text editors. That's just how I roll. RenderDoc is a great tool that's written by, I believe it's Crysis, the guys who wrote Crysis, just to really let you dig into the GPU pipeline and what's happening at each stage of things. You can inspect textures and geometry, draw calls, and the whole state of the GPU. Really get down and dirty inspecting what your application is sending to the GPU and why it's going horribly wrong. It's been invaluable over the course of my engine work. I use GLFW for window creation because it's easy. C++ standard library, of course. It's probably slower than rolling my own arrays and vectors and lists and stuff. But if it doesn't show up in the profiler, I don't fix it. Qt for my GUI, or Qt, I don't know. I can't say Qt, it's just silly. Qt is how I say it. GLM, this is a really great math library if you're looking to do anything in 3D graphics and you're wondering how you get your quaternions multiplied or your matrices multiplied, and how do you get a camera to point at something and then express that as a matrix transform. GLM will help you out big time. It's been an invaluable tool for me. Just for networking, eNet, that I believe came out of a game called Sauerbraten, or the Cube 2 engine. And it's just a very lightweight UDP networking library. No mess, no fuss, just works. I really like that. I do a lot of work with video. A lot of my background has been in video processing, so I'm always wanting to play videos and get the audio sync of videos working correctly and blah, blah, blah. FFmpeg, indispensable tool in Linux for that stuff. API is a little bit unstable, but you can't argue with the functionality. And GStreamer, I use GStreamer when I need to send stuff across the network that is video-like. And so, when I set out to sort of try and put something together, I'd sort of realized that the commercial engines were not going to support my use case. Trying to do something with an existing OpenGL engine was going to be too slow. At this time, the extensions that would allow reasonably fast OpenGL paths to OpenVR to work were not present. So I figured, well, I'll just do it from scratch. How hard can it be? I wanted to, in hindsight, right, I probably wouldn't have done it. But anyway, I wanted to optimize specifically for VR. I wanted something that was going to support my crazy ideas in VR and do that kind of specifically. I wanted a platform for my experiments. That's really, a lot of what I do is just playing around with stuff and trying stuff out. I want to be able to ask a question and answer that with code, I wanted to make it lean and fast because that's what sort of drives a lot of graphics programmers and me as well. It was an opportunity to learn Vulkan. If you don't have a reason, you don't do it. And a whole lot of other reasons. It's like, why not? And just to touch on, what other things need to be implemented to get a sort of a basic, piece of functionality together. You need some I/O. You need to be able to import meshes, models. You need physics. At least you need to be able to kind of push stuff around or have objects interact with each other. Animation. It's like you need to be able to animate stuff in some way. Shadows are, for me, completely necessary. Stuff without shadows it just looks terrible. And for me, video support was a must-have. Multi-user networking. My plan for this eventually is to create a sort of some kind of VR communal kind of social sort of space. Maybe it's a very nebulous plan, but multi-user networking was a must. 3D audio is really important in VR. It gives you a whole set of other cues, and because you're so immersed, good audio adds to that a lot. It needs a scripting language because who wants to recompile the whole engine just to make a penguin jump this way instead of that way. And I was really interested in creative tools in VR, paint, interactive geometry, being able to sculpt and influence the environment in a very dynamic way. So those were kind of my motivations. And so the architecture, that sort of informed a few decisions there. For me, the focus is not on eye candy. I didn't set out to make something that had, all of the latest sort of shader techniques and stuff. I just wanted it to work and work fast. I wanted to minimize draw calls. If you're at all familiar with 3D graphics optimization, draw calls are really your enemy. The more draw calls you have, the slower things go. This is mitigated by Vulkan to some extent, but it's still, the core constraint on how fast the GPU can crunch through your load. I wanted to use texture atlases where possible, and I was quite inspired by, John Carmack's work on megatextures in the Rage and other engines going forward. Paging textures in and out of GPU RAM is really interesting. I haven't quite got there yet. I got horribly sidetracked, which I'll touch on later. I wanted to just sort of do as much as I could in a single shader because I didn't want to, prematurely kind of end up in this situation where I was just juggling all of these resources to get things done. I just wanted to keep things super simple. A very minimal scene graph. I'm not even sure if I have parent-child relationships outside the physics engine. I wanted to really multi-thread the GUI, the video decode, and all that stuff. So multi-threading was quite a goal for me because that's the other thing that often works against you with 3D engines is if everything bottlenecks on a single thread, it sort of binds everything up. And just with the networking, latency is key in VR. So I wanted to reinforce that with the networking as well. So it's sort of first-person shooter inspired, UDP, very small state packets, just try and minimize that. And for my purposes, that works fine. And I also wanted low system requirements. At the time I sort of embarked on this, I didn't really have a job, so the best GPU I had was a GTX 770, which is nowhere near what Oculus or Valve say is minimum for VR, but I was able to do 90 frames per second sustained in VR, no problem, and it ran about 300 frames per second, without being, synced by the OpenVR submission. So with Vulkan, where do you even start? This is something that I get asked, by the very rare, in the rare case that someone is actually interested in 3D graphics and Vulkan, they say, where do you even start? And really, this is where I started. I read some stuff on the internet. I started hacking. I followed vulkantutorial.com. That's very good. And many hours later, and I'd underline that many. I think maybe I lost the underline style there, but it did take a lot of hours to get this cube on screen. But it was cool. I was like, yes, I've painted something in a window with Vulkan. It's like, wow, that's neat. Most people look at that and they go, well, Pete, that's crap. That's a single cube. What are you even, doing? But where it really clicked for me is that stuff like this. I sort of did a really brief integration of a physics engine, and that's I think 2,500 cubes, all with their own shader load. Everything, each cube is completely independent draw call, completely independent state setup, and that runs like with less than 1 millisecond per frame. It's super fast. And that was the moment where I was like, okay, this Vulkan thing, it's got something going for it. And so I kind of moved on from there. And the last time I gave this talk, I had a bunch more slides, and I kind of went into a little bit too much detail. So I'm just going to kind of skip over some of the stuff so I can get to some of the other things. There's animation in there. Integrating OpenVR. This was my first test of Vive controllers and physics. Just being able to touch this thing and it would trigger some movement. Like I said, it was my first test. I like to show people my unpolished work because you never get to see that normally. You never get to see that this is what it looked like before it looked amazing, kind of thing. Bit of networking here, again with eNet. This is like 2 clients there. I'm waving my controller around and moving the view around, and you can kind of see there's 2 players in the room, sort of looking at each other, and there's a video playing in the background. All that's multi-threaded. It runs really well. I'm quite happy with it, with the shadows and all that stuff. So I'm still working on some of the avatar stuff, but yeah, it's kind of cool to get to that point. And some experiments. This is some stuff I was doing with GStreamer, where this is a webcam that I'm sort of waving around the office that's playing, really quite low latency video, and it's got audio as well. You can't quite hear that. But that was cool. This is a Kinect streaming my living room, or my living room at the time. So this is streaming over the network, point clouds that I can kind of bounce around in. And this was one of the things that I really wanted to experiment with. And Vulkan's low overhead means you can just kind of just get all these points in GPU RAM and just throw them at the GPU, and it's makes stuff possible that I would kind of struggle doing efficiently with OpenGL. And here's another little example. This is me watching myself in VR. And one of my friends, I don't know, this is probably going to violate some code of conduct, but one of my friends said, wow, you can watch yourself masturbate while you masturbate in VR. And like, yeah, sorry. And another thing, this is my poor man's tilt brush, which is using sort of stand-in textures and programmer art, but that's the trigger that's modulating the width of the stroke there. So you can kind of paint stuff in 3D in this VR world. And this is kind of where I sort of wanted to get to when I set out. It's like, well, I can actually, create this geometry and just have fun in VR and do this stuff. It's neat. That's kind of what gets me going. So moving quite along, after doing this for a while, I had kind of got my stuff to a bit of a point where, I'd sort of reached a bit of a plateau, and I was doing various pieces of consulting work for other companies around Wellington. There's a bunch of VR startups, none of whom have any money, so, it's like, Pete, could you do this for us? Yeah, I could. Are you going to pay me? No? Oh, shit. Oh, well, I guess I'll do it anyway. But one day, a friend of mine in an IRC channel posted me just a single line of text, which was, he kept hassling Mozilla, saying, when's Firefox VR going to be supported? And they said, we're actually looking for contractors. If you know of anyone doing C++ and graphics, have them reach out to us. So I was like, okay, why not? So I sent an email to the head of Mozilla Mixed Reality. He got straight back to me and said, we're really interested. I sent him my Twitter, and he hired me just like that, just with showing all of that stuff. So I was really happy about that. And so this thing up here, this is the very first Vulkan Mozilla interop. This is Mozilla or Firefox rendering to a Vulkan texture that's been imported into OpenGL, bound as a render texture, and rendered to. If you're at all familiar with the challenges of doing IPC with zero copy, leaving it on the GPU on Linux, this is kind of a big deal. And I was really happy to kind of get this far. But then this one is actually a friend of mine's project called Crypto Voxels. It's 3D World. This is a separate program being driven by Mozilla. That's just a viewer there. So the input is going through the browser there, and it's rendering to a single texture and displaying that in a Vulkan application. That's just, all it does is displays the texture. So this is kind of my next step. And this is using the OpenGL external memory objects extensions for Vulkan. So this works on AMD and NVIDIA. It works across display platforms, whether that's Xorg or Wayland. I haven't actually tested it on Wayland, but I assume it does, assuming there's a Vulkan API. Theoretically, it will work on Android. It will work anywhere you've got a Vulkan driver with those external memory object extensions, which is kind of cool, because previously, in order to get memory from one process to another, you would either have to go through the X server or you would have to go through the DRM layer of the kernel. It was really hard, and there was no standards involved. And trying to make that work on NVIDIA, AMD, Intel, etc., I just threw up my hands, and this is the stuff that I've kind of been waiting for to do this kind of thing. But that's not to say there aren't problems with Mozilla, WebVR stuff. Getting it to work was actually quite tricky. It took me a while. It took me, basically months of part-time work to make this function correctly. Mostly because of inconsistency in Vulkan drivers. NVIDIA and AMD kind of have differences in how they do this stuff, which you kind of have to go into the driver source code to understand, which is great on the AMD side because you can do that. So, that is a big win for AMD. I was able to just okay, why isn't this working? Look in the RADV source code. Oh, that's why it's not working. That's stupid, but it's why it's not working. Okay. And so that helped me along there. The lack of documentation around these extensions and the lack of people actually doing this stuff, I think it's really just Valve and me. There's a couple of people doing some initial Wayland compositor stuff, which is cool. But it's nice to, I guess, be on the bleeding edge. I'm kind of a little bit, I'm pretty stoked with that. Optimal texture formats are one of these things that aren't documented at all in the drivers, and I sort of needed to make a few guesses around some of that. I've come up, because there's no documentation, I don't know if my hack actually sort of is the right way to do it, but it seems to work. And this is Firefox rendering to the Vive. The frame rate in the video is actually quite low, but that was since fixed. And so this was a big milestone for me with this work. It's really cool to actually get this working. It's actually running in the Firefox window. It's displaying to the Vive. Yeah, that was cool. And so the viability of Vulkan-driven IPC for this kind of application is definitely proven. There's a lot of areas in, I guess, the Linux graphics stack and in the Linux application space that could really make use of zero-copy GPU texture IPC, I think. So, if any of you guys have ideas or want to talk to me about how that could happen, happy to talk about that. And there's also some proof of concept code I've got up on my GitLab. That would make me really happy to share that knowledge and help anyone out. There's some really good performance you get out of this stuff. That's really the reason why it's done that way. And thanks, Mozilla. I'm pretty sure there's someone from Mozilla down here. I believe she might be doing the next talk in this room. I don't see her here. I don't actually know her. So if you are here, thanks, Mozilla. You paid me. It was great. And this is just Firefox running Sketchfab, and this is the display window. So this is mirroring what you see in the Vive. And this was sort of my real test. This is quite a complex application there. So, I kind of got it to the point where, off-the-shelf websites that make reasonably complex use of WebVR and things like that, they do work on Linux. And it's a little bit hard to see in this video, but it works pretty fast, fast enough to be usable. So that was kind of problem solved or milestone hit for me with this work. Unfortunately, I was a little bit cut short in the contract, and Mozilla couldn't extend it for legal reasons, apparently hiring New Zealanders, I don't know. But that sort of moved on to opportunities with Collabora now, and there's a couple of other people who are sort of interested in general terms in what I'm doing. So it's really, I guess, for me, achieved something of a dream of being a professional graphics developer with Linux technologies. You know, I mean, it would be easy to go and do Unreal or Unity development and make games or other 3D content, but you know, I'm really passionate about Linux and really passionate about using Linux as a platform, possibly because of my history with, you know, both VFX, you know, where Linux is heavily used, but also going back, you know, many, many years, decades to, I used to work for Catalyst, you know, it's people from Catalyst represented in the room, shout out, you know, great place to work. And that really, you know, influenced my path big time, so cool. You know, just while I've still got a few minutes, I will take questions, but just thought I'd touch on some of the other work that I'm doing. You know, using the PSVR. PSVR is a cheap HMD. It actually is pretty cool. It's got really good ergonomics. It doesn't have hugely high resolution, but it makes for a great setup, I think. And it's got an interesting tracking system. It's based on stereo cameras from Sony. And you know, one of the things that I wanted to do was kind of set out on this path to actually make that function. Haven't quite got there yet, I have to say, but I had to go down quite a few rabbit holes just to get it to display nicely and do some stuff that I wanted it to do. So that involved doing, you know, distortion, reverse engineering. You can see I've made this, it's hard to see possibly, but that's a little 3D printed cup that goes over the lens. It kind of puts the camera where your eye is, and so you can, you know, solve distortion from the point of view of the eye. You know, it's complicated and silly, but it's really interesting work. So those distortion tools are also up on my GitLab somewhere for free if you're interested in that sort of thing. I'd love to have some help on that side of things, because it's something that, you know, what I've got kind of works well enough for me, but it's not perfect. So yeah, and this picture here, that's my MacBook Pro. I know that's terrible, but that's running a cube map stereo image viewer for a company that I do some consulting for. Unfortunately, it's closed source, so I can't talk too much about it. But yeah, the PSVR works really well in a limited kind of resource system, and yeah, for viewing video and VR, it's kind of neat. Moving on to the optical tracking side that I've been sort of working on, one of the things that needs to be done is, you know, you need to isolate the LEDs so you can blob track them. You need to subtract the background of the frame so that you're only tracking the things in the frame that are moving. You need to do singular vector decomposition, which is essentially a way to come up with a pose or the best fit 3D transform to match a set of measured values to a model. And you've got to kind of put all that together and make that run in real time and make it robust against, you know, blobs dropping in and out of frame, et cetera, et cetera, et cetera. And so this was my very first attempt at tracking a single LED on the front of the PSVR. And this is kind of cool. This is OpenHMD with the PSVR in my engine, and it's kind of sort of working, you know, which was a big buzz for me. It's not working well enough to, you know, put out there, but it's kind of neat, you know. And this one is some application that I sort of wrote to, you know, pull this whole process together. So you can see me waving the PSVR up there. I've turned the LEDs on in the front. Unfortunately, the projector's really killing the contrast, so you can't really see the blob tracking, but those little dots there, that's the position of the PSVR as I move it around. You know, you can see it kind of working. So after I extend this a bit more, you know, I'm pretty confident that we will have a positionally tracked VR headset that works with OpenHMD as open source for Linux, which will be pretty cool. So that's pretty much about it from me. So do you guys have any questions?
So I saw you're using point clouds. Is that using
Connect V1. Oh, Joel saw me using some point clouds, and he was asking if that was the Connect V1 or the Connect V2. And it is the Connect V1, mostly because the Connect V2 has like an IR, infrared frequency that doesn't play nicely with the Lighthouse base stations from Valve. So if you want to use a Connect in the same room as a Vive, you'll have a bad time unless it's an old Connect 1, which works flawlessly. So that's why I used that. It's just Linux. Oh, sorry, I have to repeat the question. The question was, I always do this, is the work that I've done for Mozilla only on Linux or is it for all platforms? And it is only for Linux because, you know, Windows already works. macOS probably, you know, Apple, who knows what they're doing? No one really knows. I certainly don't. And it's probably not a priority for them. They do have support for their Android. The Android headsets like Oculus Go and things, they've got their own browser, Firefox Reality. You know, they've sort of got a whole program that is aimed at supporting those devices specifically. But yeah, Linux VR support was a bit of a hole, so I'm you know, really happy to have been able to contribute to that.
Thank you very much. Full token of our appreciation.
Oh, thank you.